We're back to this Graetz Musica 417. Since the last report, what's been done is pretty basic. The first thing is I got a bit tired of seeing the dusty faceplate and knobs, so a little bit of a cleanup was in order. It came out pretty well. Fortunately, none of the knobs are damaged. The faceplate is absolutely perfect. All it needed was a good clean. And this was done just with soap and water. When removing this faceplate, the back was also cleaned up. There's a lot of dust. I'll point out that the piano keys have not been in any way cleaned up yet. The dial lights that were burnt out, there were two of them, one on this side and one on the exact opposite side were burnt out. These lamps actually fit in and light up that tone control indicator, that red and white thing that you see in the picture. The same applies to the other side. This is the bass level, the other one was treble. Those were also cleaned up. Everything was fairly well cleaned up before putting the faceplate back on. So we have a good basis to carry on and go forward. What I tend to do is try and repair or finish parts of the radio as I go along. This is not usually one of the prime priorities, but this is for my personal satisfaction. So what we have now is all the dial lamps are working, the two that I've just mentioned and these two at the top here. The dial knobs are working perfectly. A little bit of oil was placed in all the junctions and joints just to make them flow a bit smoother. The actual indicators were touched up with a little bit of red paint just to make them brighter and more visible, which tends to help quite a bit. And as far as cosmetics, so far, that's about it. The way I like to do this is I like to go in stages. The first one is usually the power supply. Make sure that that's all working. Make sure the levels are fine, that the capacitors have been changed, that need to be changed. The ones that aren't are tested. Selenium rectifier checked. We know that works because the radio powered up. How well it works and how much ripple is in there, we'll find out as we go along. So what I prefer to do then is first the power supply, then the PA system, the power amplifier stage, and then go back into the actual workings of the radio. What I've done so far is I've started following the mains input wiring. We see there on the bottom left, you see the switch. Now we know that switch was damaged because somebody put a different switch in parallel. That one has subsequently been repaired, and here it is. It's a toggle switch with a very different type of toggle. The toggle is actually a different system that allows you to use this button, and it pushes it backwards and forwards. Now, all it needed was for it to be cleaned up. This particular one, fortunately, is old enough for it to come in a removable backplate. Two screws were taken out there, and the actual back end came off, allowed me to clean it properly, test it, and mount it together again. It's working perfectly. So that was put back in place. It's now functioning as the normal on-off switch. And the funny thing they put on the side there has been removed. Next we come to this stage here. What we see there, the two thick brown wires, are the mains input. It comes in and a wire goes off which comes to the switch that we've just looked at. It switches on or off, comes back, and it then is ready to go into the selenium rectifier, the AC section of the selenium rectifier. The capacitor we had there, the blue one you see is a replacement. The one we had there is an old paper cap which was leaking dramatically. Now that is across one of the mains lines to ground, and is used to remove RF and other noise going back into the system. We could actually leave it out, but since I had one of these X caps, and this is actually, yeah, this is an X cap. It's a safety capacitor which you can put across. This one is the same value, or approximately the same value. It's 4.7 nanofarads. The other one was 5. I've put it across, and so we've replaced the damaged one, or the dangerous one, for a safer one, and remained or retained the function that the original radio had. The other wires have been, or the soldering has been cleaned up, and so what we have here is mains coming in, going off to the switch, coming back from the switch. The two then go into the transformer, the power transformer. One line goes straight into the power transformer. It's that little black wire on the top there. The other one is around the side, or rather at the back, which goes to the voltage selector. Now here's the voltage selector, which is quite interesting in itself, in that it allows you to select between 115, 117, 220, 240, I believe it is. It's now set to 220, 240, and it actually has the fuse built into the back end. The little yellow wire in the middle is the one that comes back from the switch, and it then is going to be selected or tied in to the respective primary winding of the power transformer. In this case 220 volts or 230 volts or whatever it is. My wiring here, or my mains, gives me about 235, so it should be safe enough. Coming out of the transformer we have the secondary winding, which is connected to the selenium rectifier, the two AC parts of it. The AC comes in, gets rectified with the selenium rectifier, comes out as positive and negative. The negative is wired directly to the chassis, and then the positive goes off to the B+ lines. What I've done here is I've also fixed the selenium rectifier to the chassis. If you remember, it was lying around flapping in the wind. It is a lot safer now. We may decide to take this out later and replace it with a bridge rectifier or 4 diodes in bridge rectifier format, but I'll see first what the voltages produced are. So coming back to this little strip here, we have the positive and negative voltages resulting from the selenium rectifier. The negative is wired directly to that middle peg, which is the ground. So the chassis is at 0 volts. The positive is that red wire with, or rather the white wire with red stripes. And from there, it goes off to a different point here on the other side of the chassis. You can just see it there. And we'll follow it from there in a minute. What you see right in the middle of the screen there is the point where the white with red stripe wire comes in. Now what we have there is raw B+. It is the raw voltage from the selenium rectifier, the plus line. It has gone nowhere else till now. This is the first stoppage point. And what we see there is a blue wire going off, another whitish, or is it yellow with red stripes, going off below there, and we see a capacitor also connected to that line there. So that's this capacitor here. It's also in pretty grummy shape. Now we'll go to the schematic and see what exactly it is that we're looking at. If we follow the schematic, what we have here is we've come in, we've checked the switch, that's fine. We go off to one of the primaries and we have this capacitor to ground, which is the one that's been replaced. It's a safety cap. The other primary is connected via the fuse, via the voltage selector at the back, and goes off to mains. So that section is complete. We then have the secondary coming out, going to the selenium rectifier. And we've checked that, and that's complete. One side of the selenium rectifier, the negative output, DC output, is connected to ground. We've checked that. The other one is here, and this is the one that goes to the point that we've just seen. There's one capacitor, 50 microfarads to ground. It's the first smoothing cap. If we follow the line, so that's one of those three wires, one of those three connections we saw on there. One is obviously the filter cap. If we follow this wire here and across, we're looking for another two. And if we go up there, up there, up there, up there, here's the first point. This one goes to one of the output transformer terminals. So that's the other wire we saw. The capacitor we saw is this one here. Now this is a 5 nanofarad capacitor across the primary of the output transformer, and it connects to the output, or rather the plate, of the EL84 power tube. And that's what we see there. So we are here. Now if you remember that first 50 microfarad capacitor we saw, the first filter cap, it is actually inside this can. This can has three capacitors, 50 plus 50 plus 4. I would guess, I haven't looked on the other side yet, but I would guess that there are three wires coming out of it. That means that each of the capacitors' positive side is one of the wires. The negative is connected to the can because it is directly connected to ground via the chassis. Now what I noticed here, and it's fallen off, but what I had here, in that little hole at the top, there was a little blob of something that had bubbled out. So this capacitor has seen better days. However, when I switched it on, there wasn't that much hum. So the filtering was still happening. I'm not sure just how bad it is. Now, what I'm going to do is leave it there for now. I would normally remove this and stuff it with new capacitors, but for now I'm going to leave it, see how we go, test the ripple on each of these points and see if it's bad or if it's acceptable, and we can always come back and do that later. The reason I'm a bit reluctant to dive into this one is I've got the capacitors, that's not a problem. The problem is actually the way this can is connected to the chassis. Now, with some of the radios I've worked on, Sabas namely, they're connected on with a screw. They actually come off quite easily. This bugger is actually chucked through, twisted, soldered on, and it's a nightmare. It's going to be a nightmare to remove it. So if I can get away with it, I won't. There is one other alternative, and that is that I can actually remove the connections below and replace the capacitors in different formats, different places on the underside to do the same thing that these are doing, but connect them on the underside, which makes it a hell of a lot easier. What we're looking at here is the AC line voltage, and we have 233 volts AC, and it's coming across to where the primary is connected on the inside. So 232, 233 volts AC. What we're measuring here is the output of the transformer. We've actually got 234, which is damn close to the input voltage. So this transformer seems to be a 1-to-1. And here we have it, the output of the selenium rectifier, 242, 243 volts. With 235 volts going in, what you should see rectified is the AC voltage times about 1.4. We should be getting 300 and something volts coming out DC on the output of this if it were lossless. Obviously it's not. The selenium rectifier actually does produce quite a high voltage drop. What this tells us is that if we change the selenium rectifier or replace it with a bridge rectifier, silicon diode bridge rectifier, we're going to get a much higher voltage on the output. It may well be too high for what we need. So the decision to change out the rectifier has to be carefully pondered. What we'll get with 4 diodes is the AC input voltage, 234 or so, times 1.4, which comes to about 340 volts. I'm not doing the maths right, but it's about that, 340 volts, minus 2 voltage drops across the diodes, which is 0.7 each or so. So we're still looking at about 100 volts above this, and I'm not sure that we want that. So we'll leave the selenium rectifier in for now and make that decision later, because we may well have to put in some resistors or a resistor in series with the output just to reduce that voltage. Another interesting measurement we can take here is on the output, the positive and negative B+. If we change the meter to AC, we're getting 5 volts of AC. Now, what this is the ripple on the positive supply, 5.3 volts. It's the ripple which is being smoothed out, or there's an attempt to smooth out this ripple by the filter caps, and specifically the one that we've just mentioned earlier, the 50 microfarad one. Now 5.3 volts doesn't seem like much, but we'll find out later. This is a Class A amplifier, and Class A amplifier does demand a cleaner supply. At the output of the bridge rectifier, the selenium rectifier, should be 265. And we're getting that, 240 something. It's not that far off. It may seem quite a bit. It's about 5% off, but it's not that far off. Certainly not as far off as it would be if we changed it to diodes. 240 to 265, we've got a 25 volt difference. Change it to diodes. If the theory works, we're in the 340 something volts range, and that would be a heck of a lot higher than what it should be. Another reading which I haven't looked at yet is this, the heater voltage. What we're getting here is 6.5 volts. Now it should be 6.3. This is because my mains voltage here is not 220, it's actually 235. So it's a little higher than the 6.3 that it should be, but it's close enough.